Okay, let's take many big ideas of the chapter so far and provide a summary. Okay, so one thing that we saw earlier is you might have a line integral over C of a vector field, capital F with an arrow, dot dr with an arrow. Now we won't re-go through the calculation, but there's a connection with an integral that looks like this, like the integral p dx plus q dy, but not as long as you have the following situation. As long as you identify, you make the notational connection that your vector field capital F is equal to, and your first component would be capital P and your second component would be called capital Q. Okay, if you do that, then you actually will have the integral over C of p dx plus q dy. Again, we won't review that here. We're just stating it. You need to go through the work on your own. And then so now that we have this, which is right there, then basically citing Green's theorem, using Green's theorem, and using that C is equal to the boundary of D, you would have the double integral over D of partial derivative of Q with respect to X minus partial derivative of P with respect to Y dA. Now, let's comment on the following thing. This right here, I think is hard to... This part here is easy enough to remember. But this part right here, I think this is hard to remember. And I don't want you to have to go look it up all the time either. I want to give you something that's going to be easy to remember. So next time, tomorrow, right? Next time we're going to come up with something here that's easy to remember. Just as a preview of next time, let's comment on the following. Let's say this. If lowercase f is a function of multiple inputs, okay, meaning multiple input variables, right? So meaning like little f is like little f of, f of x comma y, or f of x comma y comma z, that kind of function, then the gradient of f is a vector field. We know that from before. Okay, the gradient is actually a vector field. It's a function-like thingy. I mean, it's a function where you have multiple inputs like x, y, and z again, or maybe x and y, but the output is a vector. Now, the new thing that we're going to do next time is if capital F arrow is a vector field, there is actually going to be two new objects that we're going to create out of this capital F. So one of them is called curl of F. So then curl, curl of F, is a related vector field. So out of the vector field capital F, we're going to get a new vector field that's called curl of F. So from a vector field, a vector field. And we're also going to get a thing called the divergence of F, div of F, as it's usually just noted. And this is going to be, just like this was, a function of multiple inputs. Okay? It is a function of multiple inputs. So we're going to create this creature here. So out of a vector field, we're going to create this thing called curl of F. We're also going to create this thing called divergence of F. So these will be defined, right? So this curl of F thing, this divergence of F thing, don't worry about these right now. We're going to define these tomorrow. But the key point is that this easy to remember thing, first of all, these definitions are easy to remember, okay? But then the key thing is this easy to remember thing, it's really built off of the curl of F. So that's rather nice.